Okay, so we're starting the recursion and financial unit for our unit 3. So really what this is we're going to look at financial like scenarios or rules and things like simple interest, compound, home loans, depreciation. We're going to look at all those things. All we're doing is looking at those things but writing the rules in recursive language. So what you see, what is this recursive language? So if you have a look at this, we've got this little scenario here. It says Johnny wants to save money for the future by investing in a low-cost listed investment company, Argo. Each week, Johnny is given $250 and for his part-time job, and he deposits this into his share fund for his parent, and his parents give him $500 to start this long-term savings plan. Assuming no dividends are received, so that's saying assuming he gets no extra interest or anything, he's just getting the amounts he's putting into the fund. This is how we're going to do it. So if you look here, we're writing down how this is the recursive model or way you would write this scenario in recursive language. So you can see the VO, that was the initial amount, yeah? So here he initially got $500. And then you can see what this means is how he gets the next, say it was the next week. The next week, he would take what he had the week, so this would be the next week value, is he takes the current week, current value, and he adds $250 to it. And so that's how we get it. So that is a recurrence relation. So when you write it out like that, where you tell what the initial is with the VO equals, and then you write a rule of how you keep finding the next value, that's a recurrence relation. That's all that is. And then what we can do is this would be annoying if we had to find, so we could go week by week, but maybe we want to know what he is by, halfway through the year. What's he going to be on? So that would be week 26, yeah? So that would be annoying if I had to keep on adding $250 to the one before. So what you do is you can create this nth rule. So this is a different formula. So sometimes we call it the nth term, or we might say the nth rule. And we could use it like this. And so what I'm saying there, if I had to find, say, week 26, I would use that rule and I'd say 500 plus 250. Now, because see how the n was 26 here, so the formula says to times by n, so I times by 26, and that would tell me how much that is. So I'll just do that for you so you can put an answer there. Sorry, just going to do that. So that's an nth term. So they might say, so it ends up being 7,000. So they might ask you for that. Now, we often use the letter V. I will use V because value. So I'm talking a value of an investment, value of a loan. But they can use other letters. So this down here, we've just got it in another letter. It doesn't matter. It means the same thing. They just decided to call the amount. They might say A for the amount, okay? So it doesn't matter what letter's there. It's still the same. This still means when you see n plus 1, all that means is the next term. This is the rule to get the next value, and this is how you do it. All right. Okay, so what we're going to talk about, obviously when you have a rule of how to get the next term and things like that, we create a sequence. It's a sequence of numbers that are relating, like the same thing is getting. So if you have a look here, we've got a sequence of numbers, and every time 2 is getting added onto it. So this is a sequence. If I was going to write a recurrence relation for this sequence, I could say, right, VO, and here it is. This is my VO. This was my initial one, so I'll say is 1. And then I could write how I'm getting the next one. So how I get the next one is I take the one before, which is Vn, and what am I doing? I'm adding 2. Okay, so there you go. So this was, if you look, our recurrence relation has a starting point. So this was the starting point, and then it has a rule like that, but it's the n+1 rule. So whenever you're asked for a recurrence relation, you should be writing those 2 things. The initial VO, or if they use another letter, whatever letter, and then a Vn+1. Okay, so if you had a look here, we've given you another example. So we said when we had 10, we started with 10 and we added 5 every time. So here I've created a recurrence relation for that scenario. I said VO was 10. How do I get the next one, which is how I say that in recurrence language, is Vn+1. And I use the one before and things. So there's another example. So we can do these recurrence relations. You can do them on your calculator. This is doing it recursively. So there is a difference. Sometimes they say show it recursively. So when you've got to show it recursively, it means you have to show step by step every one, how you get the next one using the one before. So we can do them on our calculator to help us step it out a little bit easier as well. So a sequence is generated by a recurrence relation of VO equals 300, and then we have this rule here. So what the rule is actually saying is that you're going to times it by 0.5, and then you'll take away 9. So how you'd get the next one. So if you did 300, so say that was VO. If I was finding V1, I'd do 300 times 0.5, and then I'd minus 9. So that would be 141. Okay? So what I'm going to show you is how you can do it on the calculator. So what you do is you type in your VO here and press enter, and you'll end up with it over there. And I want you to do this on your calculator with me now. So when you do that, then what happens is, so you've got, you want to set your first one there. So it's over on the right there. Then you want to tell it the rule. So this is what I want it to tell. I want to tell the calculator to do this. So right after you've pressed enter and you've got 300, if you press now times 0.5, what you're going to actually see is you should see answer come up, and it should say answer times 0.5, and then write minus 9 and press enter, and then what you should get is 141. Does everyone get that? Yeah? Then all you have to do, if you keep pressing enter, enter, and enter, it should keep producing the next one. Does it doing that? Yeah, and you can see it's showing you recursively every step, and then here's the answer. So then it says if I want my first 5 terms of the sequence, I can I just copy them out from the calculator. So see here, this is the first 5 terms, but if you were labeling the values, this was actually VO, this was actually V1, this was actually V2, V3, and V4. So, but this is showing the first 5 terms of the sequence, okay? But if they ask you what is V3, make sure you've gone, you go, 3 after the VO, okay? All right, so here's some exam questions to help you practice and to see what happens. In finance and recursion, it's unit 3, and that's why this is the first question in the exam on finance, and the question 17. So this is what you could expect to be your first question. So they want you to do the first, it says consider the recurrence relation, and we can see that is a recurrence relation because it has an AO and an n+1 rule. And it says find the first terms of the recurrence relation. So into your calculator, I just want you to do the same thing as again. You press 2, press enter, and you get like that. Your 2 over there. And then this time, you want to say times 3 plus 1. So it will be 7. And then if you do the next one, it will be, so essentially, and then you keep pressing enter, it'll be 7 times 3 plus 1, which is 22. And then you'd have 20, keep pressing enter, 22 times 3 plus 1 equals 67. So it said the first 4 terms. So there's 1, 2, 3, 4. So my answer is E. I'm going to pause it and let you guys try the next one. So with this next one, it says find the value of P3. So if you were doing it on your calculator, you chuck in the 2 and you get the 2 there. And then you're going to be times by 3 minus 1. So you would get, what would that be? That would be 5, yeah? No, yep. And then you do 5, and then it would be 5 times 3 minus 1, which would be 14. And then you do 14 times 3 minus 1, it is 41. Now, see how they said they wanted P3? That's because this one was PO, this one's P1, this is P2, and that's P3, okay? So the answer is 41. Okay, if we've got the next one, it says the number 13 appears in the sequence when. So if you look, you would have TO is 10, T1, if you do it on your calc, you're just adding 3. So T1 is actually 13. That one was pretty easy. Now with this one, down here, this is where they're sort of, it's written, this one was last year. Now it's written a little bit different because it doesn't have the VN or its RN here at the start. So what you could do is I could rewrite this rule, and I'm just going to put the RN part at the start. So really this is a positive 2 and that's a negative RN. So really what you're doing when you pop it in your calculator, you would have 2, and then what you're doing is you're timesing it by -1. Why am I saying -1? Because it's a negative, and then you're adding 2. So let's do that, and when you do that, you get 2, 0, 2. Now it wanted R2, so this was 0, and this was R1, and this is R2. So R2 ends up being positive 2.
Why don't you just go 2 more?
Okay, so we were just, what we're doing there was just sort of warming you up and talking about what a recurrence relation looks like. And so now we are now going to head into the actual financial scenarios and talk about using recurrence relations, okay? So the first one we're going to look at in the first couple of chapters is we're going to look at either linear growth or linear decay. So when you say linear, so what that means is when you have linear growth, we would see the value, say over the time in the uses, we will see it go up and it will be a straight line. And it's a straight line because the same amount is getting added every time, yeah? Added. So we can see that. So over here, this is an example of a recurrence relation of linear growth. So you're adding the same amount every time. So when we talk about a value or of an investment going up, we say growth. If it's going down, we say decay. So we've got linear decay. So if you want to draw a little diagram of this one, it would be the value over time. You'll see it go down in a straight line. And it's always the same amount minus being minused. Yeah? Or sorry, subtracted, I should say. So that's what we're going to look at first, these two types of linear growth and linear decay. And what they actually are, linear growth is actually simple interest. So when we talk about simple interest, the same amount is being added on every time, okay? And then when we talk about linear decay, it's either flat rate depreciation or unit cost. It's always a same amount getting taken away. So we say D, we might say D is the common difference. All right. So these two things like this. These are recurrence relations, yeah? So that's when they ask you for recurrence relation, we're writing something like that. When we're asked to find the nth rule, this is different. This is the rule we want to use when we got to find way ahead. It's not a recurrence. So you'll just see the trigger word is the rule. And in your summary sheets, you're going to see I'll call it the nth rule. Yeah? So, and you'll see it in the questions. If they say find the rule, you're most likely finding the nth rule. If they want a recurrence relation, they have to say the words recurrence relation. So you can definitely get away around this unit by just underlining exactly what they're asking and just going to that formula in your notes. Okay, so let's go through. So here, if you have linear growth, let's just write next to it. So this is the recurrence relation. So that's a recurrence relation. And underneath is this is the template for a rule, an nth term rule. So an nth term rule. We use that when we're like trying to find way ahead. We don't want to keep going step by step to get there. We want to go way ahead. So therefore, that's for growth. And then decay, here's the recurrence relation if it was a decay thing. And you can see the only difference here is there's plus and minus. So that's where you be careful. So decay is take away, subtracting. So this is the recurrence relation. And this is the nth term rule. Oops, sorry. So down here in question 1, this is out of the textbook. I'm just going to do them with you. So it says to write down a rule for AN. So that's pretty much saying the nth term rule for each of the following recurrence relations, which is true. They're giving me recurrence relations. So if I look at A, question A, now I can see this is growth. So I'm going to write, it's going to be the nth term. I'm going to write it like that. So I'll just write the template first so you can see it. Okay, so when I actually write the nth term rule, what is V? Oh, I actually should use A because they're using A. Sorry. Oops. I'm going to take that on. I'll use A for them. They're using A. All right, so it doesn't matter. You just change it to A and AO. So what is the initial value in this first scenario up here? What's the VO, or what's the initial one? 4. So there I put 4 in the formula, plus it'll be n times, and what's the D up there? What are they adding every time? Up there in A, question A, what are they adding every time? 2. So this could be a formula to get the value of this scenario at any time. So you will often probably see them though, they will put the 2 in front and the n after, because that's the way we normally write algebra, isn't it? So here's the nth term. And then they want me to calculate A20. So if I want to get A20, that would be 4 plus 2 times 20. Okay? So it equals 44. All right. Is that making sense? I'll just do one more. I won't do all of them, but I'll do B with you. So we can see it's a decay. So I'll be looking at this formula. So to get the nth term, I have to write VO. I can see that's 10 in this scenario. And then I write minus, and it'll be n times D. Now I can see D is 3, so it'd be 3 minus 3n. Or I could have wrote n times 3. You're not wrong if you write n times 3, so just we like to write it like that. Okay, and then they want me to find A20 in that scenario. So it'd be 10 minus 3 times 20, which would be negative 50. Is that right? Yep. And there you go.